So now that we've talked about states of matter, I want to spend a couple of minutes talking about something called intermolecular forces. When we watched the Eureka video of the molecules and solids, they mentioned how there was an attractive force between the particles that was causing them to both attract and then repel. Remember, that was that molecular dance that they talked about. Well, those forces have a specific name, and they're called intermolecular forces. So let's break down what that word means. Intermolecular forces are the forces of attraction or repulsion between neighboring particles. So they're so it's inside, or it's between particles in a substance. So it's the intermolecular forces. So they're these forces between the particles. So they're this network that's keeping everything together. It's what's attracting the particles, it's what's repelling the particles. Those are the intermolecular forces. So the strength of the forces can change. And the strength of the forces depends on lots and lots of things. And for right now, we're going to focus on the strength of the forces depending on the size. So the bigger the particles, or the more massive the particles, the greater the strength of the intermolecular forces. So large masses have strong intermolecular forces. And smaller or less massive particles will have weaker intermolecular forces. So the more massive something is, the more massive the particles are, the stronger the forces between the particles. The strength of the forces can affect many things. One of the first things that we're going to talk about it affecting is the state of matter. So at room temperature, a solid is going to have the strongest intermolecular forces. That's what makes it be a solid at room temperature. It has such strong forces between the particles that it's holding them together at room temperature. Liquids have moderate forces. It's what enables them to stay somewhat clumped together in a liquid form, but they have some mobility because they're not nearly as strong as the solids. And then finally we have gases. Gases have essentially no intermolecular forces. We make the assumption, and we'll talk about this in our next unit, but we make the assumption that gases have no intermolecular forces. There's nothing attracting or repelling the gas particles to each other. The other thing that we're going to talk about with the strength of the forces is that the strength of the intermolecular forces determines the amount of energy needed to change the state of matter. So the stronger the forces, the more energy you need to break them. So if you have a solid, something that has really high, strong intermolecular forces between the particles, it's going to take a lot of energy to break that attraction, to break those particles apart. If you have two liquids, and one liquid has stronger intermolecular forces than the other liquid, it's going to also require more energy to break those attractions between the particles. So the stronger the attractions, the more energy you need to break them or to remove them. So finally, I want to ask you this question. Which of these two solids, so we have two particle diagrams of a solid, which of these two solids would have stronger intermolecular forces? So we know that both of these solids have 9 particles, but these particles are much more massive than these particles. So this guy has bigger particles, which means that it will also have greater greater intermolecular forces. Since these particles are bigger, they're going to hold on to each other more tightly than the smaller particles. Which means if we wanted to change each of these from a solid to a liquid, it would take a lot more energy to break the attractions for the solid with big particles. And it would take a lot less energy to break the attractions between the particles for the substance with the smaller particles. So if we were to look at these, this guy, the one with the smaller particles, would melt considerably faster than this guy because it has weaker intermolecular forces, where this guy has stronger intermolecular forces.